Okay, good morning. We are going to be talking about now our finish system or a finish system for a light wood frame construction roofing system. And Scott and I have always talked about how the systems work together. This is no different. It works with our structure on how we're going to vent the roof, and there's multiple layers to the system. Always refer to your local jurisdiction and what the codes are for fastening requirements, approved materials, things like that. But then make sure that you're using each of the components in the system the way it should be used. And this is crucial, as this is where we're going to vent our roof. We need to keep the attic not temperature controlled, but we have to let the heat escape in the summer. We need moisture control in the winter, and we can do that by introducing fresh air or a different temperature air through the vented soffit material that we would apply here to hide our truss tails or rafter tails, and let it come out either through roof pots or pot vents or continuous ridge vent. So before we get to that, we'll talk about our finish. We talked about our subfascia or our gutter board. So the next piece that we'd want to use in our system is a drip edge. This is just a piece of white aluminum drip edge. It's got a couple of components that are pretty critical, and it creates a nice clean transition between our roofing material and any of our fascia material. In this case, if we're going to be using this drip edge, we would be using a piece of metal fascia, again aluminum, that would slide up behind the drip edge and give us a nice clean cap. But there's some features on the drip edge itself that form a critical function. So what we're trying to do when we apply the drip edge to the bottom of the roof, just like we have here, one, it's a clean architectural edge and a color transition from the color of our shingles to the color of our fascia. The other thing we're trying to do is that as any water drops come down the roof, we're trying to break surface tension, and we create this overhanging lip to try to get that water drop to fall off into the gutter or into space rather than roll back and try to somehow work its way up into the system and get behind the metal and rot out our wood structure. There's a safety built into the drip edge, and it's this little kick out right at the bottom. So if the water drop would roll off our drip edge and not break that tension and roll back across the face, this has got a slight bevel to it, again, to try to kick that water drip out to the face and get it to fall where we need it to fall so we can control the moisture movement. So if we're looking into our attic here, and here's our top of wall again for reference, and this is our attic structure. Typically, we would have a drywall cap that would form the roof of this room, and then we would pump in blown-in insulation. So here, in the middle of the attic, we might have 12, 14, 16 inches, a nice big thick blanket. And in the wintertime, that's when we'll see the ice dams happen, the heat that we have in our structure can't get all the way through that blanket. As long as the blanket has been done well and blown in well, we've sealed our can lights and any ceiling penetrations for light fixtures, ceiling fans, things like that. But as you see the rake of the roof come down, and my blanket is coming across this way, we get here to the end of the roof, and all of a sudden my blanket has to get shorter to tuck in underneath the rake of the roof. The other thing that we would have is we know we want to get that insulation all the way out to the top plate of our wall to try to protect this exterior wall. There would be a blow block or a chute put in between our trusses to allow that airflow that we talked about that comes through the soffit. It goes through the chute so we don't block it off with insulation, and then it vents out the top of the roof. Well, once we get to that top plate, we may be down to only a few inches of blown-in insulation. Now, if we're planning ahead during our pre-planning with our truss engineer, we can do something that's called an energy heel on the truss, which makes the heel, the part of the truss that sits on top of our top plate, taller. And that allows us to put in more insulation, or at least the same amount of insulation that we have in the rest of the attic. Most people don't go to that step. They just say, well, we're going to have diminishing returns the further we get out. So now if we come back and look around at our roof structure again, so we know how we get some heat loss in our attic through those penetrations. We know we can get some loss right near the top plate when we were looking into the end of our attic. So let's talk about how this product is going to help us combat that. So as we get some heat loss, and let's say it's Midwest, winter, 20, 25 degrees, even 30 degrees outside, we have snow on the roof. Sun comes out, we have dark shingles, we start to heat up that roof. We also are having some of that heat loss come through near our top plate where we didn't get as much insulation as we would have liked to have seen, and we start to get some melt. So that water drop starts to melt somewhere up in the shingle and starts to roll down. Well, once we clear that top plate, which is somewhere right underneath my hand, and we get out into the soffit or the eave of the house, the temperature of the roof deck changes. Because remember, we talked about our vented soffit is right down below here. We're bringing that air up through the venting of the soffit, and it's coming out the ridge vent at the peak of the roof. That water drop now hits the cold deck of our roof. And maybe that deck is back down to that lower temperature because this part of the roof is colder than up here over our heated space. It forms into ice. Then the next drop rolls down and hits that ice. And it stops or slows down, or maybe it all started to slow down all the way down here at the edge because, like Scott talked about, we're built up a little bit. And then the next piece of ice forms, and the next forms. Well, if I have my shingle here, and it had just dropped off an edge of the shingle, it forms a piece of ice. Then the next one, it actually will go underneath the shingle and start to climb back up underneath the shingles and go up the roof. And this is our dam that is forming, our ice dam. And we can get these blocks of ice that we can't even see. Sometimes we'll see some evidence down here, but a lot of times it's happening underneath our finish layer and we can't see it. So what this product helps do is create a barrier to that moisture getting into our building. So as the ice would climb back up under the shingle, eventually it will keep climbing and climbing and climbing, but it's going to get back inside of our top plate, back inside to where the roof deck is a little warmer because of that heat loss coming through our attic insulation, and it'll form water and try to roll back out again. That's why in a lot of jurisdictions, they will require so many feet of ice and water shield, and that's to get back inside our heated structure or over our heated structure. Right. Other jurisdictions may require 2 layers or 3 layers. They may require it on all edges of the roof or in the valley where 2 sections of roof come together. And then if the pitch is low enough, right? Imagine the lower our pitch, the easier it is for the ice to crawl back under the shingle, and the slower the water rolls down the roof because the pitch is not steep. They may require, your jurisdiction may require ice and water shield over the entire structure before you put on the next layer. So we want to pay attention to that. A couple of things to point out on ice and water shield. It's a rather thick material. It's a tar-based material. It feels a little bit rubbery. It has a backing on it that we would peel off during installation so we can stick it down and get a nice good seal down to our metal, our wood roof decking, the whole thing, so we get it nice and tight. That helps create that water barrier. And then we also have another peel and stick tab at the top. If we were bringing down another row of ice and water shield, this is an area where we wouldn't want a lot of nails. So to help hold this piece of ice and water shield to this one, we'd simply peel back our peel and stick protector right before the installation. The next layer would roll over. As it heats up in the sun, it activates this strip and it bonds those 2 rows or 2 courses together.
Mark, do you know why this is sanded? This is almost like a shingle, isn't it? Almost very much like rolled roofing.
It absolutely is. And the sanding, just like the aggregate on our shingles, protects the tar product, right? Because we all know anything dark in the sun starts to heat up. And we're talking petroleum, it can get soft, it can get sticky. we're trying to protect that layer with a little bit of sand. It also helps a little bit with traction when we're up on the roof as well. But when we get up to the finish layer, that shingle, that aggregate performs multiple functions. It adds some color, but it also adds a protecting layer for the asphalt-based product underneath.
Right. Very good.
So our next layer that we would be putting on our structure, again, we go back to our plans and our specs. And for this particular structure, our plans and specs called for felt paper or roofing felt, builder's paper, tar paper. It has a lot of different terms. We're all talking about the same thing.
So with the tar paper, it comes, brought a roll around. It's just a rolled product. You'll get so many lineal feet. It's got a height. Comes in different weight classes.
Absolutely.
So it's bought by the weight class. We have 15-pound felt, 30-pound felt, 45-pound,
90
pound.
We get really, really thick if we need it. In most cases, you're going to see 15-pound, which is this product, or 30-pound.
Very good.
Obviously, a difference in cost, difference in thickness, and this is where we get another protecting layer.
Why would you want a thicker felt product?
Again, it would depend on your environment. It has a longer life, so if you're using a longer life shingle, you would want a longer life sublayer.
I see.
There's no reason to put in a high-end asphalt shingle that's going to have this nice long life if you then shortcut underneath
Right.
of it. So it depends on the layers, depends on the specs on which product that you would want to use.
Very good.
So this layer is going to go on. You can see it's got lines placed there by the manufacturer. If we do our job right, those lines will help us stay on layout so our courses are nice and straight. And we need to have our courses straight. One, for aesthetics, we need it to look good, and two, we need the shingle to function the way it was designed. We can't short our courses where we're stretching the shingle and trying to get more square footage out of a shingle. We don't want to cram it down where the shingles are packed in too close and tight, because then our stick layers aren't going to line up, our rain channels might not line up, so we really want to try to get each layer put on correctly so we can stay on course. Now, Scott, why would we need another layer? If this is so great, I'm sure this is more expensive. If we had the money, we could put this everywhere. What's another function of having this layer on not only here, but as we climb up here, this whole roof deck would be protected by the 15-pound felt?
Right. Couple different things it does, right? So we've talked about how a little bit, it's not a barrier, but it does help moisture.
Right, it's
Right.
just one of the layers that's going to shed water.
So it's that, and it's also a bond break, can serve as a bond break between dissimilar materials. And with the coefficient of expansion of materials, each material expands differently under the sun, heating up.
So we have that dark shingle we talked about.
Right.
And it's got full sun on it. It's going to react differently than the layers underneath of it
Right.
that are not only a different material, but a different temperature.
So if we would not use the bond break, then what's going to happen is that asphalt product, the shingle, is going to start settling down into the surface of the plywood. You know, we have a very, very porous surface. There's a lot of undulation in the surface, and that product's is just almost like it's melting, right? It just relaxes into it. And when it does that, it bonds to the plywood.
Sure.
And as those two materials start to expand at different rates, you're going to start to see it affect one of the two materials, right? Because our roof, our shingle systems, predicating on those shingles, each layer above, as we're traveling up the roof, bonds to the layer below.
Sure.
And that makes it so that wind can't drive rain back up under the shingles. We have the right pitch of the roof, right? But as wind, if we have a wind shear coming perpendicular to the roof, it's going to want to start to lift the tabs on the shingle.
Right.
And we'll show that to them in a little bit here. But it's imperative that the integrity of that shingle layer stays bonded. So we have to use some sort of break between dissimilar materials so that doesn't occur.
Sure. Now this can also be applied in a variety of ways. They can use staples, they can use roofing nails, they can use cap nails again. It depends on what the owner might be looking for, the architect or the engineer. Every type of fastener has its pros and cons.
So we really wouldn't want to use staples, though. I guess what I want to say is the fasteners of the utmost importance to what your situation is.
Absolutely. And we still see the machine gun style staplers where they just pull the trigger and they can go. It's fast, it's very inexpensive, but it also tends to lead to a lot of problems. If the installer slows down, you might get 30 or 40 staples in an area this big, and all we've done is weaken the roof. So again, it comes down to good installation, following the manufacturer's installation guidelines.
And also remember, the steeper the pitch of the roof, the more dangerous it becomes, the more we're trying to rip that layer off. So we wouldn't want to staple with these steep roofs, or I've seen people slide down, you know, the paper will break loose with staples, and next thing you know, you got guys coming off the roof.
Right.
So what we do, if you want to show them, we'll just use cap nails. This is what, if I had a day or two where I blacked my roof out and I'm not ready to shingle yet, because shingles may not be on site or whatnot, I can leave this exposed to the weather, right?
Absolutely. Now, as it expands and contracts based on moisture, we could get into a problem because it's felt paper. It tears pretty easy. As it gets wet and dries, it will continue to do the same thing. So if we can cover quickly, this is a great product and an inexpensive product. The cap nails provide that greater surface area we're looking for, and we can hold down this product with much greater surface area than just the head of the nail.
Right.
Now they do make, and I'm a big fan, they do make a synthetic felt. So it looks very similar to a house wrap type product. And it's a synthetic product, it kind of feels a little bit like plastic. We can do the roll, since the product is a much lower weight. One roll covers a tremendous amount of roof. I believe it's 10 squares in one roll. So we can bring out 4 rolls to the house that are only about that big around, cover the whole thing. You do have to be careful because certain brands, not all brands are created equal. With a little bit of moisture on the roof, certain brands can become slick, which is where we don't want a slick roof while we have installers up there.
Right.
Other brands have built in a little bit of non-skid to them, but the benefit of those is they're incredibly hard to tear. So if we have a concern of what may happen, we can switch to the synthetic. It's more expensive, but we can cover our roof structure, and we can have a storm come through that night, and because it won't tear, we put it down with cap nails, we can come back the next morning and know that it's still gonna be there. So you always have options when it comes to product. You just have to work your way through the pros and cons, which include cost, installation ease, things like that.
Right.
So it is a great product.
Because in residential construction, you guys have a lot more latitude to the materials you can choose, right?
Absolutely. A lot of times the builder or the contractor is the one who is defining the specs based on the plan, based on the budget.
Right.
In commercial construction, typically the contractors are not
Right,
providing
right.
the specifications. They're given the specifications.
Absolutely. The design team sets everything, and then we go out and locate material and then have to submit back to the architect for approval. So it's up to the designer, whereas in residential construction, the constructor acts more like a designer as well.
Absolutely. We're involved in the design process, or can be pretty heavily, and we're usually speccing out the vast majority of product, which provides some peace of mind because we have to provide a much longer warranty. We take on greater liability. It's comforting for me to make sure that I'm picking out what I think is the best product in that particular environment at that particular time.
Right, right.
So once we get on our various layers, it would be time to get into the shingles.
Well, let's do that.
So we're going to show today just a standard asphalt and fiberglass shingle. And this is what we call a 3-tab shingle. This has been in use since at least, what, Scott, the 1940s, right after
I would
World
say-
War II,
yeah,
or even
I-
prior to that? So we'll talk a little bit about the anatomy of the shingle. There's the aggregate we were talking about before. You can see our color layer here. There's all different colors of aggregate, so it gives the roof a little bit of a visual texture. We wouldn't want it solid red necessarily. This lets us pick up a few different colors. You'll see that only part of the shingle has color, and part of it is a different mix. This is the color that's going to show during installation because we always overlap. If you remember during our wall sections when we were talking about moisture control in our wall, we were talking about the proper way to lap things. Well, if you ever forget in your mind, what were Mark and Scott talking about when they talked about flashing and reverse flashing? Picture in your mind how a roof works. We want the water to roll from this shingle down onto this shingle, down onto the shingle that would be tucked underneath. So we start at the bottom with our first layer, and we'd work our way up, and we always lap this way. So whether it's flashing, different types of material, this for me is always a good visual on how are you going to lap product. If we ever see it like this, and again, this goes to metal flashing, house wrap, house tape, building tape, any of that. If we ever see this anywhere, we know we have a problem because this is where the water is going to get underneath the layer because it wasn't flashed properly. And since water is our number one callback, we know that a lot of things are misflashed. So let's get back to talking a little bit about the anatomy of the shingle. You can see we have some rain channels or some drip channels built in. We have a tar strip or adhesive strip that would get activated with heat, and that'll help glue down our next layer as we go.
So Mark, this is what we were talking about when we were talking about how the shingles bond together.
Absolutely.
This facilitates that. So you have the tar strip on the top side of the shingle, and then we have something on the back, right?
Right. There's a matching one on the back. It's actually covered with a little bit of a film, so your hands don't stick to it. It doesn't stick to the roof when you're trying to slide it into place. But as it heats up in the sun, and it doesn't have to be a 90-degree day, if we have 45 or 50 degrees, it'll heat up, and this little bit of a shield that's over the top of that will disengage and kind of disintegrate, and that helps bond to the layer below it, because we can only put nails or fasteners in a certain spot on the shingle, or we'll get into a leak problem. That brings up another point, Scott. When we look at our other layers down here, you always have to remember, where do the fasteners go? We would not want to drive fasteners all the way down at the bottom edge, because we'd actually poke a nail right through our ice and water shield, and we'd come out right through the front of the drip edge and have a nail showing. Ugly. We don't want to see that. Same thing up on our rakes. We don't want to drive nails too close to the end of the roof, because we'd penetrate the wrong spot. It's ugly. It's poor craftsmanship, but it's also bad for our system in leaks.
Right. And that's one thing that we're trying to prevent by applying these products, is to keep water out of the structure.
So the nice thing, most manufacturers, if not all manufacturers, include our installation instructions on every bundle of shingles. And they pretty much try to cover all the situations. They tell you where in slope restrictions, where you can install the shingle. If it's too low of a slope, you can't install a fiberglass asphalt shingle. You'd need to use something more like a roll roofing. If it's too steep, you also can get into issues. It'll give you which fasteners to use. It'll give you the fastener location so that we can actually put in the fasteners exactly where they're supposed to go. It tells you how to handle different situations, whether it's a flashing around the chimney or a valley coming down the roof, and then what our different control layers are. So if we ever have an issue, A lot of times we can pull something up on our phone, we can pull it up in the specs before we even get to the job site, but in many cases, on the packaging itself or within the packaging will be another list of instructions so that we can make sure that we're doing it the right way, because we want the warranty that's included by the manufacturer.
Absolutely.
If we don't follow this, no warranty.
And I'm here to tell you that that's the way it goes down. We had a tornado come through at my house, was that 3-4 years ago, dropped some trees, but it had blown, it's just, the tabs of the shingle just looked like leaves.
Right,
They were
flipping
in the wind, right? So it broke the seals of one side of my house. So the adjuster comes out to my house. The roof is about 6-7 years old, so it should still be in the height of its usefulness, right?
Absolutely.
It hasn't really started to deteriorate yet. He comes in and he could start marking the layout of the shingles. And in a minute here, we'll go into what the layout is, this stair-step methodology. But they did a 6-inch offset on my roof, so they just laid back and forth out of a center run and then
Right.
laid out to both ends of the roof.
Right. Which is fast.
It's huge. It's amazing to lay shingles that way.
Right.
But unfortunately, what I found out, it voided the shingles warranty.
Absolutely.
So then I had to assume the cost of the storm.
Right.
The storm's damage to my roof.
Right.
So if the people that had done the installation had read the directions, and let's get that straight right now, guys. You can't put things together without reading the instructions when we're playing with the big kids.
Right.
Okay, it's not like it at home because of these situations.
Absolutely.
You know, if I buy a cabinet at IKEA and I have to take it home and and put it together, that's one thing. Somebody going up on their roof and installing a roof is something completely different.
Absolutely.
Can a homeowner do it? Absolutely.
Right.
But they have to go by what the manufacturer says.
Yeah. And follow all your safety precautions, everything that we would typically have to do. So let's talk a little bit about where we're going to fasten. We get our first course. Well, we'll talk about also starter strip and things like that. So
you want to just go up
we've
the
got
roof
our
with
layers. We'll go up. Now, if I just come right out of the gate and say, I know what I'm doing, I can install shingles, and I put my first layer down, and then we would stagger, which we'll show you what that looks like. We'd stagger our next course. We can already see that we have a problem because this part of the roof is going to be showing, and we can see through the color, and we can see that we have the wrong color showing through our shingle. That's because we need to use some kind of starter strip. And that can be either a manufacturer's pre-made starter strip, which comes with some cost, or a lot of times we can take another shingle, we can reverse, and we'll pick up some of our aggregate color, and we'd run this as our starter strip. So what that does is give us tar layers where we need them, things like that. But I like the manufacturer's starter strip because it adds another tar layer all the way down at the end where we cannot put a fastener. And that helps that lift of the roof that you were just talking
And
about.
I'll show you what we used to do. So I'll cut one for you. How about I cut it?
Absolutely.
So, as Mark said, you can go right to the store, to the lumber yard, and you can buy all the different pieces of the roof. You can buy your starter strip, your common shingle, you can buy ridge cap.
Absolutely.
All of this, and believe me, there are several different types of shingles you can choose from.
Sure.
You know, T-locks, diamond locks, all these different shingles, but they all go on similarly, right? So there's an added cost. Of course, it's going to cost you more to buy the starter strip than a regular bundle of shingles. So us always being cost conscious and adhering to budget, what we can do is we can take the shingle, flip it over, and I can cut these tabs off. And I can just run it, and the great thing about shingles is you don't need to get a skill saw out to cut them, right? All you need is a utility knife and sometimes a straight edge. So all I need to do to start making my starter strip is get rid of these 3 tabs. So I can just take my knife and I can start down the shingle and I can whack the tab of the shingle off. Now, what Mark said was that by flipping the old shingle, the old way of doing it, when we first started roofing, when Moby Dick was a chub, like Mark said, we just flip the shingle over. But what happens is our tack strip down to our felt paper, right? Because we're always trying to seal up down on the eaves so water can't get underneath the product. He said that, or Mark said that the store-bought, this is shifted down onto the drip edge.
Right.
So what we've done with cutting our own is the same thing.
See,
As now you can see,
there's the one on the back, there's the one on the front.
now we have a starter strip, and now we're going to seal the shingle, the starter strip, down to the layer below it with the adhesive on the backside. And then our first course of standard shingles is also sealed down on the eave. Now we have a situation where we can prevent, if everything's installed properly, we can prevent water penetration from occurring.
I'm just going to tack this in so we can show our next layers. So we would keep our nails away from the bottom edge, away from anywhere where we'd penetrate our drip edge again. We'd run our starter strip out, and I've even seen starter strip run up the side, so we have that adhesive layer up the side to keep the end of the shingle from flapping, and then it'd be time to start running courses. So we've got...
So Mark, can we just lay a shingle down on top of that, or is there something to this anatomy of the shingle that helps us do layout?
Absolutely. We're looking at our rain channels or our tabs right there. We're looking at the edge of the shingle because the manufacturer continues those channels all the way to the edge. And then we've got some spacing tabs that help us where we run our courses, just how we wanted to stagger our courses in our floor decking, our roof decking. We stagger our courses in our concrete block and our brick. There's little indicators that are cut right into the shingle. You can see them here on the back that help us set our stagger across the top of the roof. And that gives us a chance to lay in our stagger. We'll show you how the courses lay out without having to try to mark the shingle.
Right.
Shingle is hard to mark because of the very tough aggregate on one side, and then you don't want it to show by accident.
Because of these tabs, we don't even need to pull a tape measure out when we're shingling.
Yeah.
We need to do some layout
We have to
maybe
do
for
some-
coursing that we're going to
Absolutely.
utilize, but we no longer, like we do when we cut wood, where we got to measure, mark the measurement, and then go to the saw and cut it. Here, when you're up in your roof and you're on the roof, what you don't want to do is run up and down, right? Up and down the ladder. So they've made it to where it's really just kind of no-brainer. And if we look at this, these tabs, we have a 6-inch from the end. We have a tab at 6 inches. Now where this drip edge is here, or this drip channel is what you call it.
Yep.
The drip channel, that represents 1 foot. Then we come to the center, right in the middle, we have a center tab, right in the middle of the shingle, its length, and that's at 18 inches. So you can see how this is working out, right? 6, 12, 18, 24, 30, 36. The shingle's 36 inches long. So we've just, cut it into 6-inch tabs. That's perfect for how Mark's going to show you how we stair-step shingles.
And we want to get our first shingle laid out. Let's slide that one up. We'd follow the manufacturer's instructions. They have a 6-course layout, which is the pattern, and then after those first 6 courses with the layout, you just keep repeating them until you reach the top of your roof, which then we switch over.
So we put a full 3-foot starter strip down, 3 foot long. Can we
Exactly.
run the first layer of shingles at 3 feet?
We wouldn't want to because we're starting to line up our seams. And if we're not careful, that just creates that spot where we can get a penetration. So we'd want to start out with that shorter starter strip, or we could start out with a partial shingle.
And I just happen to have one here, Mark. So you can see, if you pull the camera in, we have a full tab here, we have a full tab here, and here we have a half tab or a 6-inch tab. And what we've done is is I came in, I flipped my shingle to the back side, and if I flip this over, you see how the shingle lays now. So what I have to do is I have to cut this 6 inches of the tab off. So I come back over, because I have this 6-inch mark or tab on the shingle, that tells me where to cut it. So I just come in with my knife, score down the shingle, and it's gone. And now we could lay that in like Mark's got there. I guess on the next one I should have taken a foot off, because now I can come to the center of my first drip line, and now I can cut it. Now we have our next course.
And what I like to see, you know, it's always fun to watch somebody who does something very, very well for a living. We will see the roofing crews, because they're getting paid by the square, right? 100 square feet, they have a going rate for the area to lay that square of shingles. You will actually see them sometimes move so quick that they fly the shingle past the edge of the roof. And they won't even take time to cut it, because they need to get across the roof as fast as possible. So they'll find that tab in the shingle, if you hold that for a minute, and they will fly it out to that first cut, or whichever one they wanted to use, line it up. Well, in this case, we'd have to go out to our second cut, because we already cut our first one, and let the shingle hang. And then we're going right to the top of the rain channel. We take our next course right to the top of the rain channel, line it up, and then after the fact, somebody would come down it and they'd knife right along the edge of the metal and get a perfectly clean cut aligned with the drip edge. So a lot of ways you can do it. All of them work correctly. We want to watch our alignment. We want to watch our nail placement. Again, refer to the manufacturer's instructions. We don't want to get our nail placement too high in the shingle, and definitely don't want to get it too low in the shingle, because that would create a shiner, is a common term, where we have that shiny nail head showing kind of half-mooned right underneath, because we got our nail too low. And that's just the place where we're going to get moisture that would come in.
So the placement of the nails.
So we're going to refer to our installation instructions provided by the manufacturers. Depending on the wind rating of the shingle, they'll tell you to use 4 nails or 6 nails. In this case, it says low and standard slope. Use 4 nails for every full shingle located shown below. So you can see the sealant strip, and right below the sealant strip is a nail right above the rain tab, a nail right above the rain tab, and the last nail, and they're saying come in from the end of the shingle 1 inch. And that follows manufacturer specs. That way we get our warranty. So if we were to follow along here, of course we'd have our nails below in the course, but we'd come in 1 inch.
We'd put it right below that drip edge.
We'd have one right above our rain channel, and we'd have one at the end. Now this we really have to pay attention to, again, at the end, that we don't get too far out and get into our edge metal.
Right. And one thing you want to make sure is that the angle of the nail's proper. You can see how these heads are flat and indented into the shingle. That's what you want. What you don't want is it driven in at an angle. See how we're doing? And we leave that.
That's going to cause a problem if somebody goes up and steps on the roof for maintenance purposes or something like that. It starts to wear on the shingle above it. It's not got the holding power that it should. It's just going to cause a problem. And remember, a lot of roofers are not using hand-driven nails. They're using guns. They're very, very rapid, but you have to maintain the proper pressure so you don't overdrive or underdrive the nail. So Scott, do we have one more chunk of shingle?
Sure do.
So I just want to show on the back, if we align our next tab and we'd slide over again, so now you can see how my rain channel or drip channel is staggered to 2 below. So I'd check, but look at how everything starts to line up on our seals. We want that nail right below that tar strip per the specs, so it would seal right there, and that gives us another chance on that wind-driven rain. If we get a little bit of leak around that nail head, we've got the shingle down below it that will let it run out through the shingle. But we want to seal right above it so we can stop that from driving up this way and getting behind the preceding layer.
Right. And as you can see that we're putting, in essence, with every new layer, 2 rows of mechanical fasteners for every row of shingles.
Right.
You're always just nailing below your tack strip.
We would have had the row down here, and now we have the row in the shingle above it. So we're holding it down at 2 points, then using our adhesive strip as another form of sealant, and keep trying to build our layers. So we can continue this all the way up. If we had roof pots or roof vents, that would help venting, but the common venting method now is a continuous ridge vent. You can see our roof decking at the top of the shingle has actually been held back. That creates a gap on either side of our ridge, and that's where we want the air to escape. They make all types of ridge vent. They make solid. It's made out of a special plastic that can take sun damage and things like that. They also make a soft ridge vent. It's the best way I can describe it is kind of looks like a scouring pad.
Yes.
It's about 16 inches wide or so. It's got all those fibers like a scouring pad does. They fold that down over the gap in the roof. And those fibers are there to kind of provide they call it a tortuous path. So if a water drop gets in there, it has to go this way, this way, this way, this way, this way, and try to get through thousands of fibers before it could actually drop down into your roof. But we're there to try to move air. So then we would take, again, you mentioned before, Scott, the manufacturer might sell something called a hip and ridge shingle. And it's pre-cut for you or perforated, and it looks just like a 3-tab, but it's got perforations in it, and you can just snap it at the perforations and create your ridge cap or a hip cap. In our case, we need that ridge. So if you were doing it without the perforated ones, you just come right through your rain channel, give it a little score line, snap it yourself, and what we've done is create some ridge cap. So after our ridge vent would go on, we'd simply fold this down over our ridge, put in our fasteners on each side. You're gonna have to use a much longer fastener, and then we just stack them up just like we do down here, so we get a continuous line of color all the way across the ridge. The nice thing about ridge vent is we have continuous ventilation. If we picture those roof pots, which are still used a lot, I know, they are down from the ridge, sometimes 2 or 3 feet. Well, we all know that hot air in the attic is gonna rise to the highest spot. Plus, we're also concentrating the heat that comes out of the attic in a few spots along the roof. If we do continuous ridge vent, we're venting across the entire ridge.
And all the heat's coming out.
And all the heat. We're at the highest point, and as that heat escapes, it creates a lack of volume in the attic, and it kind of creates the suction action through your soffit and pulls in the air to help lower the temperature of the attic. Even if it's 90 degrees out, if it's 120 or 130 in the attic, it's better to be pulling in that 90-degree air because at least we're venting the heat. So it's a great product. There's a lot of different venting techniques that can be used. You just have to figure out what is the best venting technique for our structure, our environment, and our shingle or our finished product. This is just an asphalt shingle. They make, and fiberglass. They make composite shingles. They make concrete tiles, terracotta tiles, clay tiles, steel roofing, standing seam, copper, you name it. There are dozens of different products out there. So budget, environment, look, performance, longevity all play a factor into what the finished product is going to be on your project.
Absolutely.